All right, in this video, we're going to be going over the next example in number 3, example 3, on the Unit 5 Day 2 notes. This one's a hot mess of a problem. It's actually not even in standard form first, so let's write it in standard form first. So I'm going to have 2x minus 5y minus z equals negative 8. Negative x plus 2y plus 3z equals 13. And then x plus 3y minus z equals 5. Now that I have that, I can see that I actually want to change row 1 and row 3. So we're going to swap those two rows first. So doing that is going to give me x plus 3y minus z equals 5. Row 2 is going to stay the same. Negative x plus 2y plus 3z equals 13. And then row 3 is now 2x minus 5y minus z equals negative 8. All right. Now with that, I can just add row 1 and row 2 as it is right now, and that will eliminate out the x. So I'm going to go ahead and do that. So this one, row 1 plus row 2, and that's my new row 2. So my row 1 is going to stay x plus 3y minus z equals 5. My row 2, x plus negative x cancels, and then I have 5y, negative z plus 3z is plus 2z equals 5 plus 13 is 18. And row 3 is the same. That is 5y, z equals negative 8. All right. Now I need to multiply row 1 by, looks like a negative 2. Negative 2 times row 1. That's going to be my new row 1. So it's going to be negative 2x minus 6y plus 2z equals negative 10. Row 2 and row 3 both stay the same. And then I need to add row 1 and row 3. That's going to be my new row 3. So if I add row 1 and row 3 together, let's see. So the first row isn't going to change. And I'm actually going to convert it back to, so I'm going to multiply row 1 by the negative 1/2 to get me back to x plus 3y minus z equals 5. That just gives me smaller values to work with, and it's a lot easier to do that. Now when I combine these two together, what I end up with, so I have 0x, so minus 11y plus z equals negative 18. All right, now I need to figure out what I'm going to do with these row 2 and row 3 so that I can get rid of the y value. So for this one, what I want to do is I want to get rid of the y value. So I'm going to need to multiply the top row by 11 and the bottom row by, row 2 by 11. So 11 times row 2. So that'll be my new row 2. And then 5 times row 3, and that'll be my new row 3. So I need to multiply both in this case. Row 1 is going to stay the same, so I have x plus 3y minus z equals 5. And then row 2, 11 times 5, so 55y plus 22z equals 18 times, do not know that, 18 times 11 is 198. And then 5, so negative 55y plus 5z equals negative 198. No, totally not that. 5 times negative 18. There we go. Negative 90. There we go. Cool. Now I add row 2 and row 3. That'll become my new row 3. Row 2 plus row 3. That'll be my new row 3. So row 1 stays the same. That's x plus 3y minus z equals 5. Row 2 is 55y plus 22z equals 198. You may see that you can actually now also take row 2 times the inverse of what we just multiplied it by earlier. And then that will be, so multiplying it by 1 over 11 to get us back to here. We will be doing that eventually. This is 0y plus 27z, and then 198 minus 190, or sorry, minus 90, excuse me, is 108. So now I can substitute back to find these values, solve for this one first. So if I divide both sides by 27, I get z equals 4. I said I was going to back substitute. Remember, I could use this one here. So we have 5y plus 2 times 4 equals 18. So 5y plus 8 equals 18, minus 8 on both sides. You get 5y equals 10, divide by 5, you get y equals 2. And then we can use x plus 3 times 2 minus 4 equals 5. X plus 6 minus 4 equals 5. X plus 2 equals 5. And I get x equals 3. So I have 3, 2, and 4 as the solution to this ordered triple. Join me in the next video as we then go over attempting to solve an inconsistent system.